All right. Hello and welcome to Optimizing Automation with KUKA, introducing iiQKA Screw Fastening Basic. Key takeaways of this session include how iiQKA Screw Fastening simplifies robotic screw fastening setup and deployment, key features that improve process accuracy, consistency, and documentation, and some tips for optimizing your fastening workflow with KUKA robots and smart tools. My name is Jules, and I'll be your host for this session. Thank you for joining us today to hear from Matt Beyer, Sales Application Engineer from KUKA Robotics. If you have questions for Matt during the presentation, you can use the Questions tab found at the top right of your screen to type those questions in. We will address as many questions at the end of the presentation. Now, I'll pass it on to Matt.
Hi there, and welcome to this webinar on the KUKA software option package, iiQKA.ScrewFastening Basic. Today, I will describe how to use this option package in the configuration, programming, and testing of robotic screw fastening applications. Following this webinar, you should understand the following: that iiQKA Screw Fastening Basic is a KUKA software option package for second generation KRC5 robot controllers using the iiQKA OS2 operating system. Use this option package to configure, program, and test robotic screw fastening applications. The software provides configuration and monitoring utilities to set up screw fastening hardware and special programming commands for common screw fastening functions. Finally, the software provides programming templates for fault handling and error strategies. Here's the agenda for today. We will begin with a quick product overview and then discuss the system configuration before talking about robot programming and testing the system. We will then finish up with any questions you may have about the software package. First, a quick overview of the product. iiQKA Screw Fastening Basic is a software option package that extends the capabilities of KUKA robots that use iiQKA OS2. The software supports specialized commands for screwdriver motion, screw feeder control, and vacuum generation, as well as configuration and monitoring screens for setting up screw fastening hardware. Finally, the software provides manual status keys for quick control of the vacuum and blow-off valves directly from the teach pendant. This software has a few requirements for use. It runs on second generation KRC5 robot controllers using the iiQKA OS2 operating system. It uses iiQWorkSim for installation, configuration, and offline programming, and it depends on three other KUKA option package files, or KOP files: the iiQKA UI, UI Creator, and UserTech option packages. Now let's discuss the configuration of the software and how it can be set up for use. To use the software, the option package must first be installed into iiQWorkSim, then assigned to and deployed to a robot. This installation process is straightforward and takes just a few steps. These are to first launch iiQWorkSim, then select in the File menu under Options, Add-on. Click on the Manage button to launch the option package management window shown here, and in the window, you'll click on the plus sign to add a new option package. After you hit the plus sign, you can browse to and select the iiQKA Screw Fastening Basic KOP file to install it. And after you do install the KOP file, don't forget to assign the option package to the robot in iiQWorkSim so that it will be installed when the user transfers the instance from the PC to the controller. So here is a quick video clip showing how to assign the option package to the robot using iiQWorkSim. First, you will select the robot and then access the option package configuration section under the robot's component properties. Here you'll see assigned options as well as available options, and you can select the new option package from the list of available options that are currently installed in iiQWorkSim. Once selected and assigned, the option will be installed in the instance, and you can then use the features and functions provided by the software. Later, when the instance is transferred to the controller, the option package will be installed on the robot. After the option package is assigned to the robot in iiQWorkSim, the entire instance can be deployed to the robot controller. This will transfer the configuration as well as the programs that have been developed in iiQWorkSim offline. This is accomplished on the configuration screen using the wizard associated with the Deploy Configuration button. The wizard will guide you in the deployment process step by step. After the software is installed and the configuration deployed to the robot, the option package settings can be configured directly from the robot's teach pendant. The main menu of the robot controller provides a section for configuring option packages installed on the robot. Just click on the option package name to show the configuration screen for the screw fastening option package. The configuration screen for the option package has several features to help you set up the application. This section contains configuration settings for the digital outputs of the robot. These outputs are the control signals sent to the screwdriver, feeder, and vacuum generator. In the digital output section, you can select the robot output to be dedicated to each function of the screw driving system. Most functions require only a single output to be assigned. However, the program mode setting is a multi-bit signal of user-specified length that defines how the system will output the program number to the screwdriver controller. For this function, the user specifies the starting output number and the program length, which is the number of bits in the signal up to 4. The program mode option can be configured in 2 ways. So the program mode can be configured in bit mode, where only 1 bit is true in the signal at any one time. And the program number is represented by the position of that bit in this full signal. This limits the program number to the number of bits in the signal. Alternately, you can configure the program number in binary mode, where all the digits in the signal are evaluated as a binary number. The maximum number of digits in the signal is limited to 4, and thus the largest program number that can be represented is 15. Moving back to the configuration screen, this section contains configuration settings for the digital inputs of the robot. These inputs are the monitoring signals from the screwdriver and feeder. In the digital input section, you can select the robot input number to be dedicated to each monitoring signal. Each signal is shown alongside an indicator that displays the current signal state. Lastly, when the test checkbox is selected, you can set robot outputs to test those functions of the system. You can also monitor the state of system inputs by using the indicators provided next to each input signal. Now let's discuss robot programming for screw fastening applications. Let's consider a simple program. This program instructs the robot to start with a motion to the home location, then set a program number on the screwdriver, then move to pick a screw from the screw feeder. After picking the screw successfully, proceed to the workpiece to fasten the screw there, and then finally return to the home location. This option package provides application-specific commands for the screw driving functions in the program. Additionally, error handling is built into these commands so that failed screw picks or fastening operations are handled directly by those functions. I've used iiQWorkSim to program the robot and preview the motion cycle, so let's take a look at what this program does. As you can see, the dedicated screw fastening commands make our program very short and easy to read. We don't have to manually sequence I/O commands to actuate the driver, feeder, and vacuum. The software package provides 4 specialized commands for the screw fastening process. These commands are set program number, pick screw, fasten screw, and throw screw. Each command has one or more parameters that must be set for the program to function. Let's review those parameters now. The set program number command sends the specified program number to the screwdriver controller via the robot's digital outputs. The format of the program number signal is determined by the program mode selection that was made previously in the configuration screen. Remember, this signal can be configured in the bit or binary mode, and that configuration plus the bit length value controls the maximum program number that can be represented. The pick screw command is a motion instruction that contains several extra parameters related to the pick screw process. These parameters are: the pre-distance parameter specifies the approach distance to the screw feeder pick position. The after distance parameter defines the depart distance from the screw feeder. The parameter vacuum wait second is the number of seconds the robot will wait at the pick position for the vacuum to activate. Rotation correction is a function that can be activated for the screw pick operation if the screwdriver supports it. And if rotation correction is active, you can specify if the program number is to be set during the screw pick operation and then define that program number. The fasten screw command is a motion instruction that contains 3 additional parameters related to the fastening process. These parameters are functionally the same as those in the pick screw command. They are the pre-distance, the after distance, and the program number. The throw screw command is a point-to-point motion instruction that contains 2 extra parameters related to the throw screw operation. These parameters are the pre and post distance settings for the approaching and departing the screw location. The application of the throw screw command can be seen in the error handling strategy used by the system. One of the user functions that's provided by this software is the throw screw method. This method can be used when an error occurs and the system must automatically discard the currently gripped screw. To use this function, the user must first define the path to the throw screw location by programming one or more motion points in the method. Then, the controlling variable can be changed from the default behavior, which is to stop the robot and post a message, to the throw screw method instead. So then, when errors are encountered during the pick screw or fasten screw operation, the robot will automatically call the throw screw method and discard the screw before attempting to repick or refasten with a new screw. Now let's discuss how to test and monitor the system. The configuration screen provides a test checkbox that allows you to force system outputs to the active state. Simply click on the checkbox and then select each output that you wish to activate. Note that these virtual buttons act as signal state indicators when the test checkbox is not selected. While the configuration screen has indicators showing the state of the inputs, forcing an input to a particular state requires access to the signals in the Inputs and Outputs section under Diagnosis and Monitoring in the main menu. Here you can select an input and force it to a specific state, true or false. To do so, select the input and choose Force in the Parameter section, and then set the forced value. The system will indicate when inputs are forced by including a message on the Inputs and Outputs screen, and also including a message in the notification section of the main menu. Finally, here are the icons used for the status keys and their location on the Smart Plug and Smart Pad. These buttons can be used to quickly actuate the vacuum or blow-off valves. So that's it for the presentation. I hope that was useful and understandable. At this point, I'd like to take any questions you might have about the system or the software option package.
All right. Thank you, Matt. As Matt mentioned, please take some time. You can use the questions tab at the right-hand top of your screen. If you've had any questions come up, go ahead and type those in, and we will address as many as we can. We have one question that came in. How do you monitor the digital I/O of the screw fastening process?
Great question. The configuration screen provides signal indicators showing which outputs are asserted or forced. So you can view the signal states during configuration directly on the configuration screen. Additionally, all robot I/O can be viewed using the Inputs and Outputs screen found under the Diagnosis and Monitoring section. So if I pull up the web HMI that shows the screw fastening application, I can see that under the main menu, under option packages, I can see the configuration screen, and I can see these state indicators as well. And that's how you would monitor the I/O of the fastening process. Great question.
Awesome. Thank you. Another one here. What screw fastening systems does this package support?
Yeah. So this technology package wasn't designed for any specific screw fastening system. Rather, it has been developed for any screw fastening system that supports digital I/O for control of the driver, feeder, and vacuum.
All right. Another question. Do you need a computer to configure the option package settings?
While the option package must be installed using iiQWorkSim, which runs on a PC, all option package settings can be configured directly on the Teach pendant without needing a PC. So in process or in development, you can install the application package and then use the functions of it directly on the Teach pendant without needing a computer to configure the option package.
All right, thank you.
Mhm.
Another one, how does the system detect or correct fastening errors?
So the system is configured with functions to do the fastening and picking of the screws. There are error handling routines built into those functions that will automatically be invoked when the error signal is received from the screwdriver controller. So when the robot goes to pick a screw or fasten a screw, if the screwdriver controller asserts the error bit, the robot will either stop and post a message, or it'll invoke the throw screw method, in which case it'll move to the throw screw location and discard the screw.
Awesome, thank you.
Mhm.
One more here. How does iiQKA handle variations in component or like different material types?
Right. This technology, this option package, it has no settings for material types. Rather, it relies on the screwdriver controller and the programs that are defined there in order to set up the particular fastening program when the driver is actually being called. So there are ways to specify the program number on the screwdriver controller, either directly with the command to set the program number or to set the program number as part of the screw pick command. But there isn't any particular setting for different materials or different screw types.
Okay, thank you.
Mhm.
Can you set or slash read torque or other parameters?
This technology package doesn't support feedback in that respect. The only monitoring signals that are viewed are the fasten, okay, and error, and screw ready from the screwdriver controller. So if you want to implement torque monitoring, you would have to do that in expert level code.
Okay, thank you.
Mhm.
Can this be Ethernet IP or physical I/O?
So this system is designed for direct I/O and not a field bus. So this is expecting that you're wiring directly to the outputs that are presented on the robot controller.
Perfect, thank you. All right, it looks like that is all of the questions that we have. So I think we'll look to wrap it up here. Thank you, everyone in the audience, for attending, and thank you, Matt Beyer, for sharing your presentation with us. If anyone has any additional questions that come up, please feel free to reach out. So thank you, everyone, and we will see you next time.
Making automation easier.